there, welcome back to my channel. Today we are tackling the art of sorting. Imagine cleaning up your messy desk. Sorting algorithm do just that, but for the data. Basically, sorting elements is arranging the elements in ascending order. Now we will break it down with three fun methods: bubble sort, selection sort, insertion sort. So let's dive deep into it. First up is bubble sort. Picture this: you are blowing bubbles, and the largest bubble naturally flows to the top. That's exactly how bubble sort works with number. Imagine you have an array. We will start from the first element of the array and we will see the element adjacent to it. And if the first element is bigger than the second element, we will swap it. Since here 6 is bigger than 2, we will swap this. So it's 2, 6. Comparing the next element, it's 6 and 8. 6 is smaller than 8, so we will not swap it. Then 8 and 4. Since 8 is bigger than 4, we will swap it. And last, 8 and 10. We will not swap it. Our new array will be 2, 6, 4, 8, and 10. We will repeat this process until our array is sorted. Now let's for the next step we will see 2 and 6 already sorted. 6 and 4 not sorted. So we will swap it. 6 and 8 sorted, 8 and 10 sorted. So our array is officially sorted. Our new array is 2, 4, 6, 8 and 10. Now let's see the coding part of it in Python. First, define the function bubble sort and we will pass a parameter that is our array. Then let's assume n is the length of array. Now we will sort it by roots. So for I in range, n minus 1, and for j in range, n minus I minus 1. If our initial element is bigger than our next element, then we will swap it. This line means the elements are getting swapped. And then we will return an array. Easy, right? Now let's see from an example. Let's run this program. As you can see, our array is getting sorted. So basically what bubble sort do is we compare the adjacent elements and we will swap them. And the process is repeated until the whole array is sorted. Now bubble sort is simple but not very efficient for large data sets. But it has a time complexity of big O n squared. Now let's move to the next. Next is selection sort. Think of picking socks from a pile. You will find the smallest socks and place it at the beginning. Here's how selection sort works. We will find the minimum element and swap it with the first element so that the minimum element can come in front. And we will repeat this process until our array is sorted. Let's take the same example. In this array, we will find the minimum element. Since it's 2, we will swap it with the first element, that is 6 at the 0 index. Now our new array will be something like 2, 6, 8, 4, 10. Now since 2 is already sorted, we will divide our array into two parts, that is sorted and unsorted. And we will now find the minimum element in unsorted array. Here it's 4, so we will swap it with 6. Since 6 is our first element of the unsorted array, so it will be 4 and 6. Now 2 and 4 are our sorted array. Unsorted is 8, 6, 10. Similarly, we will find minimum, that is 6. We will swap it with first 8. It will be 6, 8, 10, and our array is already sorted. 6 will go in sorted array and then it will check minimum element from 8 and 10, and 8 is already small and is already in correct place, so our array is sorted. Now let's see how it works in the code. So first we will define our function. And we will pass our parameter array. N is the length of our array. Now let's run the loop to access the elements in the array. Imagine, let's believe that I is the minimum element. If the element j is smaller than the minimum element, then we will again re-evaluate the minimum element, and the minimum element will be j. And so we will swap it. Now let's take an example. Let's run this program. So as you can see, our array is already sorted. So basically what do selection sort do is that we find the minimum element and we will swap it with the first element, and then we will divide the array into two parts, sorted and unsorted, and then we will check for the unsorted. So selection sort is straightforward and it reduces swaps, but like bubble sort, it has a time complexity is big O of n squared and it's perfect for small data sets. Now moving for our last sorting algorithm for this video, it is insertion sort. Insertion sort basically places an unsorted element at its suitable position in the array. Basically, the idea behind the insertion sort is that the first take one element and iterate it through the sorted array. So we will work on the same example. So for first iteration, we will take our key 2 and we will compare 2 with 6. Since 2 is smaller than 6, we will insert 2 at 0 index. So our new array will be 2, 6, 8, 4, 10. And now for the second iteration, we will take our key 8 and we will compare 8 with 6. Since it's already sorted, no need of swapping it. Then in the third iteration, we will take our key 4 and we will see with 8. Since 8 is bigger than 4, we will swap it. And lastly, for the last iteration, we will see 10, and since 10 is not bigger than 8, it will not get swapped. Now again, now our array is not sorted. So what's the catch in this? In iteration 3, when we take our key 4, it will compare it with 8 also and with 6 also. And since 4 is smaller than both of them, that's why it will be get placed at the first index and the other element will get shifted. So that's how insertion sort works. There are different iterations and we take key. We leave the first element and we start the key from our next element that is present at first index. Second element at first index. Now let's see the code. So first, as usual, define your function and pass the parameter. Let's define n as length of array. Now this is our first loop, that is our outer loop. Since the algorithm starts from the second element, we will take I equals to 1. Because the first element is already considered sorted. So now he will be our I element. Then starting with the j position. Now let's start with the j pointing to the last element of our sorted part. So last will be I minus 1 because our array begins from 0. And we will compare the key with each element in the sorted part. So while j is greater than or equals to 0 and our key is smaller than the j element, we will shift it by one position to the right. And we will continue until we find the correct position for the key or we reach the beginning of the array, just like I told you for the number 4. Now at the end, we will insert a key to its position. And lastly, we will return our array. Let's take an example. This. Let's run our program. And as you can see, our array is getting sorted. So basically in insertion sort, we will take a key and then we will insert it to its correct position. Now the time complexity of insertion sort is same like bubble and selection sort, big O of n square. These three algorithms are better for smaller data sets. In next video, we will learn about quicksort and merge sort that is better for large data sets. Thank you.